Alright, so today we're going to solve this media problem, which is 1004. It says max consecutive ones 3. It says that given a binary array of nums and an integer k, return the max number of consecutive ones in the array if you can flip at most k zeros. Okay, so I have to find the max length of the subarray, which is of ones, and I'm allowed to like switch k number of zeros to 1 basically. So given the nums array, right, 1, 1, 1, k is 2, so I can flip this, but I can't flip this, so my max would be 5. But the output is 6, so there would be some bigger one. So let's say I move here, right? I can't flip this, so I can consider these two, 1, 1, 1, 1, and 1. So this is of size 6. So is this the one they're considering? Yeah, I mean, they can even use this as well, so they're considering this. So the max is 6. Okay. Um, Yeah, I mean, the best way for these ways usually a sliding window. So I can have a left pointer and a right pointer both pointing at 0. What I'll do is I'll increment my right whenever I get a 1. If I get a 0, uh, I'll have a 0 counter basically, and I'll check every time if it is less than the k. If it is, that means I can flip that 0. So I'll keep moving on. If at any point that is more than k, that means I can't flip a 0, right? So, which will happen in our case here. So after this, when I get here, right, if zeros is greater than k, that means I can't do it. Then I need to start again. So what you can do is I can increment my left pointer and I'll do it till my zeros is again less than equal to k. So that means it will stop here, my left pointer. So this is it. Left, it founds a 0. So this is my new window. Then I'm going to keep doing this and I'll find this window. Then when it sees this, it will decrement this. It will start increasing my left window. So then my last window would be this. Yeah. So yeah, this is a sliding window problem. I'll have a left pointer starting from 0, a right pointer starting from 0. Okay, in terms of space and time, it will be off and you're not really using a space. I don't think you can do better than this. Yeah. So left is 0, right is 0, while my right is less than the length of the array, because once I reach my right pointer reaches the end of it, that's like my maximum length I can go for. There's no point in decreasing left because then that window is going to only get smaller. So while right is less than n, what I'm going to do is if my nums of right is equal to 0, right? Then let's have a counter int zeros, which is 0. I'll do zeros plus plus. Okay, and every time I get a number, if it's 1, I just keep on doing. So let's do a right plus plus. Yes, and yeah, I'm gonna check if my zeros is greater than k, because if it is equal to k, that means it's still valid. So if zeros is greater than k, what I'm going to do is now I need to do my left pointer and I'm going to do it till I get a 0, right? So while my nums, uh, actually, yeah, I don't need a f. Basically, this will be while my zeros is less than k, greater than k. What I'm going to do is if my nums of left is equal to 0, I'll do zeros minus minus, right? But if it is not, uh, that means I'll do left plus plus. I'll either way do left plus plus, right? Till my zeros is greater than k. And at the end of it, basically my window is a valid window. So I'll have, let's say, an answer which will keep track of this. So initially, let's say I don't have anything. So answer will be basically math dot max of answer and the window size. So the window size is basically right minus left plus 1, because at the end of this, right, I know that the window that I have is a valid window. It could be a smaller window or a bigger window, but that is a valid window. So I'll keep track of the max of this window. And yes, at the end of it, I'm just going to return answer. Let's run this. Okay, everything passes. Let's submit. Awesome. So in terms of time and space complexity, it is O of n since I'm using a sliding window and just going over the array once. In terms of space, it's O of 1 because I'm not using any extra space. So yeah, and that's it. Thank you.